Hello, welcome to Pseudocoder. My name is Ravina, and today we are going to look at another data structure as part of chapter 3, and that is linked list. Okay, so let's get started. What is a linked list? Linked list is a linear data structure that has data elements which are connected via links. Okay, um, Python doesn't have a standard library for linked list, so we actually implement it using the node structure that we actually learned in the last chapter in trees. If you don't know what that is, feel free to watch my previous chapter on trees. Okay, so let's get started. Let's look at what a linked list actually looks like. All right, so first thing is it is data elements. So basically nodes, correct? So here, for example, I can say that this is my node 1. Okay. And I can have multiple nodes in here. So for example, say it is a linear data structure. So say I have these nodes. Now what happens is you can actually connect these nodes using links. Okay. So here I can have, some small place to store the links. And here say 1 is pointing to 2. So we can do something like this. And 2 points to 3. Okay. Since 3 is the end node, 3 is not pointing anywhere. So the pointer for 3 is gonna be actually none. That is null. Nothing. Okay. So this is what a linked list actually looks like. Now, there are two types of linked lists. One is a singly linked list. That means that the links between nodes are in one direction. So, the example that we just looked at is a singly linked list. That means that you can see that in this node, we are going in one direction and it is actually a single link. Correct? Now there is another concept called another type of linked list called doubly linked list. Now what is that? Doubly linked list is a linked list where you can have links to both the next node and the previous node. Okay, so let me show it to you. So for example, you have this node 1, you have this node 2 and node 3. Now my one node is pointing to 2, so I can have this little space here. So okay, 1 is pointing to 2 and then say 2 is pointing to 3 and 3 has no one, so 3 is not pointing to anything, it is none. In doubly linked list, what happens is 2's next pointer is 3. Okay, but it will also have a previous pointer to the previous node. Okay, so here we'll have another place for address, and then here 2 is gonna point to 1 as well. Similarly, 3 is gonna point to 2. And since 1 doesn't have anything on the left, because 1 is the first element, then it will be pointing to, you have guessed it correctly, none. Because if there is nothing, it's going to be none. Okay, so this is an example of a doubly linked list. That means that there are two links that it is pointing to. Now a linked list can also have multiple number of links. Okay, it is not really constrained to how many links it can have, but usually it is singly linked list or doubly linked list. Okay. Now there is another concept called circular linked list. Now, what is circular linked list? Circular linked list, that means that a particular linked list is in a loop. Okay. So for example, let's say we have 1, then 2, and then 3. So suppose 1 is pointing to 2, 2 is pointing to 3, and 3 is the last element. But you'll see that in circular linked lists, 3 will again point to 1. So you can see that this is a circle and hence it is called a circular linked list. It is not necessary to draw it in a circle. It can very well be something like, 1, 2, 3. So these nodes pointing here and then this node can point here. It's essentially the address that the particular node stores. Okay, so this is an example of a singly circular linked list. Now, the same case, you can have double links, correct? So you can have something like, if this is 1, 2, 3, you can have 2, a pointer from 2 to 1. You can also have a pointer from 3 to 1. And since 3 is pointing to 1, we can also have a pointer from 1 to 3. So this is again a circular linked list, but here this time we are using a doubly linked list. Okay, so remember, two types of linked list, singly and doubly. And here you can have circular linked list. Again, it will be it can be either, it can be a single linked list or a doubly linked list. Okay, so I hope this was helpful. Now let's talk about how can you add or delete nodes from a linked list. Now this is a very, very important concept. If you are someone who is actually preparing for competitive programming such as lead code, hacker rank, you will need to know this. And I promise all the problems there uh, will need you to know this. Okay, you should know how to add a node and how to I don't know if you'll be asked to remove a node that frequently, maybe in some cases, but you are definitely going to be asked how to add a node. Okay, so keep attention to this section. This is really important. All right, so suppose you have a linked list. All right, so you have 1, 2, 3. Now we are looking at adding first. So 1 is pointing to 2, 2 is pointing to 3. Now first scenario is I want to add a new node 4 and I want to add it to the end. What will I do? What I can do is I will start from my first node. I will travel to 3, and here in 3 the pointer currently is what? Is none. That means there is nothing there. So what I can do simply is that I will point the pointer from none to 4. It's easy. I have added my node. Okay, so that is one scenario. Now the second scenario is, what if I want to add something in the middle? So I say I have 4, and now this time I want to add my 4 between 1 and 2. And how do I do that? So when you come across this situation, what you have to do is you start from the starting node. Then you check, okay, I have to add things between 1 and 2. That means that I have to get rid of this particular link. So the link from 1 and 2, I have to remove that. I want to link my 1 to 4. So 1 to 4. And excuse me, I have to also make sure that I link my 4 to 2, because otherwise it will be broken, correct? I need it to be continuous. So I'll link my 4 pointer. 4 will now point to 2. And you can see that now it is continuous and we have added 4 in the middle. Now the last case that we have in terms of addition is, what if you want to add something at the start? So say I have 1, 2, 3 and I want to add node 4 at the start. So 1 is pointing to 2, 2 is pointing to 3. This is relatively simple. What you can do is you can create a new node. So I created a new node 4, and inside my for my 4 next pointer, what I can do is I'll just point it to the start of my linked list, and I will make this one as a start. Here you have now added 4 at the start of the linked list. Now in terms of deletion, it is similar. So what you have is, say for example, the first case is I want to delete 3. Now when I want to delete 3, what I can do is I will start from 1. Okay, this is not the node that I want to delete. Then I get to 2. Okay, now I want to delete this 3. So what I can do is I can just remove the link from 2 to 3. So if I remove this, it's done. I have my linked list and 3 is removed. Okay, the second scenario here is that you have 3 nodes, and now you want to delete 2. This time you want to get rid of 2. So what you can do is, the element that is pointing to 2 will now have to point to directly 3. So that means that this pointer will be updated to this pointer, correct? And here you can see that we automatically got rid of 2. Now 1 is going to be pointing to directly 3, sorry, 1 will directly point to 3, and here we have our linked list. Okay, it doesn't matter that we did not remove the pointer from 2 to 3 because it is never going to reach 2, and since it is never going to reach 2, it is never going to reach from 2 to 3. Okay, so I hope the point is clear. Now, the last scenario, as you might have already guessed, is that you want to delete the first element that you have. So, say I have this linked list. Okay, I want to delete 1. How do I do that? So, what I can do is I will simply go and start from here and make this as my starting node. Okay, I can do that. I can make this one as my starting node so that anything before that is going to be just deleted. Okay, so this is how you do deletion in a singly linked list. All right. So I hope you now understand how to add or remove nodes. When there is a doubly linked list, you have to make sure that you update both the pointers instead of just one pointer. Okay. So previous and next. So this is all that you really need to know in order to solve any of the linked list problems out there. Now I want to take you to my IDE and explain to you the node that is there in the linked list and just show you a few examples. So see you there. The first example here is a single node. So if you look at it, you can see that it is a class single node. It has a init method here. This is used for initialization. And here you have a value. So remember, in those boxes, I was writing values 1, 2, 3. That goes here inside the value variable, and then there is a next variable that is actually currently none because all the nodes that we create are first the pointers are none and then we point it to another node. So this is the next pointer. Now let's look at the doubly node. So here the only difference is that it has a next pointer and it also has a previous pointer. So you'll see that the value and next stays the same, but it has a previous pointer. Now the name can be anything, but this is kind of standard that we use previous and next, but it can be really anything. You have to know the node definition in order to run or add, links or add values. So remember that these are just variables. The names can change, but the concept stays the same. Okay. So first what I'm trying to do is here, I'm trying to create a single node. So what happens here is I'm actually just instantiating single node and giving it the value of 1. Now let's look at it again. You can see that the initialization method here takes in a value. Okay, and then it is assigning that value to my value variable. So when I initialize the node with say 1, my node will contain value 1. All right. Now what I do is, since now this is going to be my first node, and what is the variable that is holding my root node or my first node is this single root. Now what I want to do is I want to point it to another node. Okay, so what I do is the node that is currently here, so one's next pointer, what do I want it to be? I want it to be a new node that is single node 2. So I created a new node 2 and then I pointed my first node to the second node. Okay. Then here what I do is, this can be a little advanced, but just try to imagine it in terms of boxes. So what I'm doing is I want to now create a third node, okay? And I want to point my second node to my third node. So how do I do that? I can do single root, which is the current node 1, dot next. What is 1 dot next? We just did it. 2, correct? 1 dot next is node 2. And if I want to point second nodes next to a new node, what I can do is now node dot 2 dot next is gonna be what? A new node 3. Okay. So this is just essentially saying that current nodes next. Okay. So you just have to have the boxes and current node next. Okay. This node's next is what? It is 3. So this is how I actually created a single node. Now let me actually print that out and show you. So say I now print singly root, which is the first node, and I click execute. You see that, oh yeah, you cannot just directly print the node. It is going to give you an address. You can see that here it's an address and it's saying object at, this address. So you have to print the value that you want. So you can do a dot val. I click on execute. You can see that it returns me 1. When I do single dot next, so here now what I can do is single root dot next, and then I want the value of that particular node, correct? Single dot next dot value. If I do that, I get 2. What if I want to get single dot next dot value? That will be the last variable, correct? Sorry, the last node. So here you can see that it returns me 3. So what we did here, single dot next, it is actually 3 and it is correct. Okay. So this is how you actually create nodes. This is not, I don't think so you will ever create nodes like this, because usually you will have, a list or something to go on, and then you will have a loop that will go in and just do dot next. That will be way, simpler and better way of doing it. But since we haven't really looked at for loops, I just wanted to give you an understanding of how you can just create nodes, okay? But we will cover this in the upcoming chapters. Now let's also look at how do you actually create a doubly linked list. So it is same. First the first element, and then I just created doubly node. And why do I use this? Because this is the class name that I used for my doubly node. So I do doubly node and then I provide it a value. Then I want to point it to 2. So I can do doubly linked list dot next, and then I can create a new variable. Sorry, a new node. Now I also want to make sure that, my next node also points to my first node. So how can I do that? So I can do doubly dot next dot previous is equal to the first node. So here, okay. And here I'm just playing around. So what I can do is I doubly linked list dot next. Here, this is a typo. So this needs to be 3. So I'm creating 3 nodes. And then I want to make sure that doubly dot next 3 nodes, previous node should be 2. And this is this. Okay, so this is just to give you an understanding of you have to maintain both the pointers, the next pointer and the previous pointer in a doubly linked list. I hope you liked this video. If you did, please give it a thumbs up and comment below. That really helps my channel. And also if you would like to see similar videos like this, click on the subscribe button and you will be notified about all the uploads that I have. Also, needless to say, the code is gonna be on my GitHub. All the links are going to be in the description below. If you have any questions, feel free to join my Discord channel and feel free to drop any suggestions that you have for me, or just any questions that you would like to ask. I release videos every week, so keep an eye out for that. And if you are someone who is learning Python for competitive programming, I do have a blind 75 and a algorithm data structure playlist. So feel free to check that out as well. I hope you're enjoying my videos and thank you so much for watching, and I will see you in the next one.